friends at the edge of the night at a bar of 75. And we talked about how our parents will die.
Welcome everybody. Today's lesson is all about pyramids and cones. Today we're going to learn about how to find the lateral area, the surface area, and the volume, as well as talk about some of the pieces and parts of pyramids and cones. Before we can get into solving for lateral areas and volumes and that sort of thing, we need to talk about some of the parts of pyramids and cones. So, first things first, let's take a look at some of the variables we're going to need for our formula. First, we're going to look at the letter P. We're going to look at this cursive letter L and find out what that means. We'll also look at the letter capital B. We need to find out what each one of those variables represents in our formula. Now, P, you'll remember from prisms and cylinders, represents the perimeter of the base. The capital B, you'll remember, is the area of the base. And this cursive L is something new to us. The cursive L represents slant height. Let's take a look at how to find slant height in our two diagrams up above. First of all, in our cone, and a cone has a circular base. This is our base, the circle. The regular height of the pyramid or cone is the altitude, and that's the distance from the vertex straight down to the center of the base. And it needs to be perpendicular to the base. So this is our height of the cone or pyramid. Our slant height is the distance along the side of the pyramid or cone. So the distance from the vertex to the edge of the base is what's called our slant height. Looking at an example of a pyramid, this pyramid has a square base. And now we're going to take a look at how to find the height. That would be from the vertex directly to the center of the base. There's my height. And my slant height is from the vertex down the side to the edge of the base. Now, if you'll notice, the height, the slant height, and then the distance from the center to the slant height create a right triangle. So often we're going to use our faithful friend, the Pythagorean theorem, to find our slant height or our height. Don't forget about our friend, the Pythagorean theorem. All right, let's take a look at the formulas for lateral area, surface area, and volume of pyramids and cones. You should turn to your formula sheet, and let's move down to the middle two and look at pyramids and cones. First, we'll look at lateral area. The lateral area of a pyramid is 1/2 times the perimeter of the base times the slant height. The surface area is the lateral area plus the area of the base. The volume is 1/3 the area of the base times the height. Now, the cone formulas are very similar, but keep in mind we have a circular base, so there will be slight differences. The lateral area is pi times the radius times the slant height. The surface area is the lateral area plus the base, just like with a pyramid. And lastly, our volume is identical to a pyramid. It is 1/3 the area of the base times the height. Make sure you've got all the formulas written down correctly, and then we're ready to move on to try an example. Now, these two examples are not in your packet, so sit back, enjoy the ride. For the cone, let's say we are given a height of 5 and a radius of 4. We need to find the lateral area, the surface area, and the volume. First things first, let's make sure we can find all of our variables. I need to have the height, I need to have the slant height, I need to have the perimeter of the base, I need to have the area of the base. If I have all 4 of those variables, it becomes very easy to compute any measurement. So the height was given to us. The slant height now, we need to look at using the Pythagorean theorem. So I've got 4 squared plus 5 squared equals my slant height squared. 4 squared is 16, 5 squared is 25, and that gives me my slant height squared. So 16 plus 25 is 41, which is my slant height squared. Take the square root of both sides, and the square root of 41 is about 6.4. The perimeter of my base, if we're looking at a circle, is the circumference. So the perimeter here would be 8 pi, which is my diameter times pi. And the area of my base will be pi r squared, or 16 pi. All right, now it's time to plug in some of my values. For the lateral area, you'll remember that my formula is pi times the radius times the slant height. So that's equal to pi times 4 times 6.4 for a grand total, and I'm going to leave my answer in terms of pi, of 4 times 6.4, 25.6 pi. And since we are talking about area, these should all be units squared. My surface area, you'll remember, is the lateral area plus the area of the base. My lateral area I just found was 25.6 pi. The area of my base we found earlier was 16 pi. This gives me a grand total of 41.6 pi units squared. Okay, on to volume. For the volume, I'm going to use my formula 1/3 the area of the base times the height. Let's plug in the information that I know. I've got 1/3 times 16 pi times my height, which is 5. Now, let's leave our answer in terms of pi, and we will do 1/3 times 16 times 5, and we get 26.6 pi. And since we're talking about volume, this will be units cubed. All right, let's look at an example of a rectangular pyramid. For this example, let's say I'm given a height of 10, and I'm given the length and width, so 6 and 4, and I'm asked to find the lateral area, the surface area, and the volume. Let's also say that my slant height here is 12. So let's define all of our variables. My slant height is equal to 12. The height is equal to 10. The area of the base is equal to 24. That's my length times my width. And the perimeter of the base is equal to 6 plus 4 plus 6 plus 4, which should give me 20. Now, let's plug in. We'll go through this example a little bit quicker. For the pyramid, my lateral area is 1/2 times the perimeter of the base times the slant height. That's equal to 1/2 times 20 times my slant height, which is 12, which should give me a grand total of 120 units squared. The surface area then is that lateral area plus the area of my base, which was 24. So my surface area should be 144 units squared. Lastly, my volume, that's 1/3 times the area of my base, which is 24, times the height, which was 10. 1/3 the area of the base would be 8 times 10, which is 80, and volume is units cubed. Alright folks, now it's your turn. I want you to turn in your packets and try a couple examples of our own. The first example I want you to try is on 910B. I want you to try examples 1 and 2, where you're asked to find the lateral area and the surface area of a pyramid and a cone. For question number 1, you should have found that the lateral area is equal to 4 yards squared. The surface area is equal to 5 yards squared. Moving on to question number 2, you should have found that the lateral area was equal to 54 pi centimeters squared, and the surface area was equal to 90 pi centimeters squared. If for any reason you got any of those answers wrong, go back and check your work. If so, let's go ahead to move on and find some volumes. Turn to page 10-4A in your packet. Try questions 1 and 2. Then check your answer. Alright, for question number 1, you should have used your volume formula and done 1/3 times the area of the base times the height, and gotten a grand total of 30 pi millimeters cubed. For example number 2, we should have used my volume formula and done 1/3 the area of the base times the height, and gotten a grand total of 2,000 centimeters cubed. There you have it, folks. That's how we find the lateral area, the surface area, and the volume of prisms, oh my goodness, of pyramids and cones. Come to class ready to ask questions.